Okay, here we go. Now we've got. I've done what I said I'd do. I've got the two. There's two Mark IV belts coming up, and there's a Mark V conveyor belt taking that solution over. As soon as I did that, this water line increased, and that was just simply because this product was holding up the other one. So now more is coming out. If we go out and have a look here, this is all you can see. It's running through very nicely, feeding over to here very nicely, which is you can see the actual silica is flowing a lot faster now. The ingots are just churning through nicely. These are all being made, and we should be expecting to make 120 a minute of the Alclad, the Mark V Alclad sheet. So that's it. We now have a full running solution. We'll go over here and have a look from the top, because it's quite interesting to understand the scale of setting up the Alclad sheet solution from go to woe in one location, all in a level layout. I did it this way so we could see it. The only thing we can't see here is over there is our train station that we set up for the water. So that water there runs underneath the train line and comes all the way across and underneath and over to here, and comes up underneath. So we're bringing water from way over there. Yes, there's some water here, but it was part of an earlier example of how to bring water in from remote locations. And because I'd done it that way, it's at a height that I didn't need any pumps. But this solution seems to be just churning along nicely. You can just see the Alclad sheet coming through. And that's about it. Yeah, so really the only downside that will slow the production down is when right now the train stops for a load or an unload. It stops the outloading of these. So I could, if I wanted to, put a buffer container there to unload into it first, but I'm not too fussed about that. For me, it's okay what's going on here at the moment. We've got some really nice activity. Well, this box will be filled in no time. Okay, everyone. One thing I didn't go through was what was required to make all this work. And this gets back to our fun thing of making notes. So I've got a whole bunch of notes here to make everything. You probably starting from the other end is the best way. So, well, it's two ways you can do it. You need to know what you need to make. For instance, you want to make Alclad aluminum sheet, then you need to know, well, one constructor makes 30 and requires 60 aluminum ingot and 22.5 copper. So then you go and work out, well, what I need to make aluminum ingots, and you work your way backwards. Working my way forwards from the beginning, I'm starting off with alumina solution. One refinery makes 80 fluid and 20 silica and requires 70 bauxite and 100 water. So based on bringing 480 of bauxite in, the most I could make is, I believe was 6 refineries. So the next step was, okay, from 6 refineries, it's 480 fluid and 100 silica, 120 silica is what it makes, and it requires 420 bauxite and 600 water. But you can also see that I'm bringing water in from the alumina scrap process, which is 120, so I only need 480 water. Then I've got the alumina scrap process, which makes 360 scrap and 60 water and requires 240 alumina solution and 60 petroleum coke. from our incoming fluid of alumina solution, which is 480, we can make 2 refineries of scrap. So 2 refineries of scrap makes 720 scrap, 120 water. So that's that water that returns back up earlier, and it requires the 480 alumina solution and the 120 petroleum coke. The petroleum coke, there's only one way to make it, and that is a byproduct of heavy oil residue. So it requires 40 heavy oil residue to make, that's 1 refinery. So to make the heavy oil residue, I need to actually make some rubber and use the heavy oil residue of that, which requires crude oil. So I need 2 rubber refineries to make the 40 rubber and the 40 heavy oil residue, and it requires 60 crude oil. This rubber I end up sinking because we don't need it. And also, and the heavy oil residue is used. Then the aluminum ingot, which 1 foundry makes 80. It requires 240 scrap and 140 silica. So our 720 scrap available allows for 3 foundries. The 3 foundries require, well, it'll make 240 aluminum ingots. It requires 720 scrap, 420 silica. We're already getting silica from the alumina solution, so then we need to ditch some of that. And then the silica makes, from the silica, we need 300 silica. So 8 constructors making silica from the raw quartz, and then that feeds into our, that's what feeds into our foundries. And then finally, our Alclad aluminum sheets, they make 30 and they require 60 aluminum ingots and 22.5 copper ingots. So that's 240 aluminum ingots. Divide 60 is 4, so we get 4 Alclad aluminum sheet constructors, which make 120 a minute. It requires 240 aluminium ingots, 90 copper ingots. So we actually also have to provide us with 90 copper ingots, which is our 3 smelters. Bang, you're done. It's a lot of stuff to do. Really, you need to, in my opinion, you have to write it down if you're going to be, if you want to get it working successfully. There's going to be things that go wrong, and you just have to work through them. It's not an easy process. I've actually got a problem here right now I'm going to go and look into, because we can see we're stalled. We're not bringing any, there's no scrap coming through. So I'm going to go look into that, but that'll be an overflow issue. I think perhaps I've got too much silica. But anyway, the takeaway there is notes. That they really do help, and if you really want to take it to the next level, spreadsheets. Okay, I've resolved the issue I had. For some reason, I was making either too much silica or the silica backed up, which meant that there was the foundries weren't receiving enough scrap quick enough, so the silica backed up, and with the silica backing up, that ceased all of the silica backed up in all of the alumina solution refineries. So then they all stopped producing the alumina solution, which stopped producing the scrap, which meant then the scrap wasn't being, so the silica wasn't being combined with it to make the ingots. You can see how it's a big snowball chain reaction. The way I resolved it was I put a smart splitter here where I receive the silica as part of the merging process, and I sent it overflow. Center of silica, but my overflow goes this way, and we are simply just feeding into a sink. And that way we're making points, we're not wasting too much. Possibly another solution could be to maybe get rid of a constructor, or go through and empty each machine out, but none of those issues resolve a backup issue. So this resolves a backup issue. If there's a build-up of silica, it will simply from the refineries, it will simply get purged and will not cause the dependent product of the alclad, of the alumina scrap coming through and working. And you can see now, we are just churning out ingots like there's no tomorrow, and we are now actually making our 120 per minute alclad sheet. Then this box will be full before we know it, and the whole operation will cease. So I could also put here another smart splitter, and when this is full, overflow into the sink the spare sheet, because that's more points, because this is an expensive operation.